Okay,
Okay.
welcome to Computer Science IGCSE, and here we are going to discuss about the paper pattern first. So the paper pattern
Okay.
is in front of us. Let's start discussion about the paper pattern. There we go. First, Computer Science IGCSE, and the subject code is 0478, right?
Okay.
What is the subject code?
0478.
Yes, you always need to remember all the subject codes for all the subjects. Okay,
Okay.
after this, we have two exams or two papers in computer science. So the paper one is called computer systems, and paper two is called algorithms, programming, and logic, right?
Okay.
Okay. You don't need to
Yes.
write anything. I will give you the time to write everything. So just you need to focus on the screen, okay? Don't write anything.
Okay. Yes.
Okay.
Okay.
So we have two papers. Computer systems called paper one, and paper two is algorithms, programming, and logic.
Logic.
Yes. Okay. So in computer systems, paper one, we have a code. We already know the code is 0478, but there is a component number 12. This is your component.
Okay.
Maybe in your country, the component is changed, like 13, maybe it is 13. So it's not a big deal, right?
Okay.
Or maybe it is double one. But the paper pattern,
Okay.
double one, 12, or 13 is same. The syllabus is same.
Okay.
The examination date is also same. Okay.
Okay.
And the time duration for paper one is 1 hour, 45 minutes. So we have discussed
Okay.
the code with the component number, and the time duration is 1 hour, 45 minutes. The total marks for our exam
Yes.
is 75. You don't have any choice in the
Uh-huh.
examination. It means you have to attempt the full length paper. So bad luck, no choice.
Okay.
And there is a no calculator policy. Again, bad luck, because we have some calculations. We have some calculations.
Yes.
So no calculator allowed. Okay.
Okay.
Now, paper two, algorithm, programming, and logic. What is the name of paper two? Algorithm,
Algorithms from programming and logic.
perfectly fine. The code is same, 0478, but the component number is always different, double two. So it may be double
Oh,
two, or you can say double one, or you can say, sorry, it can be 21, it can be 22, it can be 23.
okay.
So the same things are there. Now, the time
Okay.
duration again for paper two is 1 hour, 45 minutes.
Okay.
Okay. Marks again 75. Again, no choice and no calculator. But
Okay.
question that, are both papers going to be conducted on the same day? No. Both papers
Okay.
will be conducted on different days. So you don't worry, because last time we have around 7 days gap. In this series, May-June series. In May-June series,
Okay.
for paper one is of on 12th May, and paper two is on 17 May. So we have a lot of time for paper two to revise the things back.
Sir, I'm actually doing the Feb-March series.
Yes, I know. You're from Fab Mars.
Okay.
Fab Mars, yes, you will get a proper 2 or 3 days gap between the paper. So
Okay.
I think so. Inshallah, we will do that. Okay. Now, next.
Okay.
Okay, first I will give you the screenshot. I'm going to send you the screenshot, okay?
Okay.
Okay, on your number. You can check. There we go.
Okay. That's actually my mom's number.
Okay, no worries, no worries, no worries. Mom will share you, doesn't matter.
Okay.
Okay,
Okay.
I wanted to show you something about our ebook. So I'm going to share it.
Okay.
So this is an ebook.
Okay.
So in this ebook, you can see this is a title page. Maybe you have a colored. because in South Asia, we have a brown color title page. So the title page will be different. You only concerned with the two things. Thing number one, the addition. And thing number two, the
Okay.
writers, David Watson and Helen Williams. These are the writers.
I have the exact same book.
Yes. Okay,
Okay.
excellent. Okay, let's discuss the contents quickly. This is our paper number one. I told you the name is computer systems. In our computer system,
Yes.
how many chapters we have? We have
6.
Yes. But don't think, oh, it's only 6 chapters. Wow, it's very easy. Can you just think about this thing? See, this is 75 and this
Yeah.
is 7. So think about how long the chapter is, right? Again,
Yes.
it's starting on page number 180 and ends, if the other one starting on 217, it means the chapters are too much detail.
Big.
Yes. So we have
Yes.
a lot of time to complete this. Second thing, we have section 2, algorithms, programming, and logic. Again, we have 4 chapters. So again, we
Okay.
have only 4 chapters, but they are not only, the chapter number 7 is too much detailed chapter. You can see the topics. And then we have a programming, most important chapter, database, very important and a very depthful chapter. And then Boolean logic, of course, as my love bug. I love this chapter, Boolean logic. So this is a
Okay.
of our syllabus. I hope you understand it. Any problem?
No.
Do you want to ask any question?
No.
Oh, that's great. Moving back to the chapter number 1. I am going to start at chapter number 1. Let me start
Okay.
one with the, yes, there we go. So we have a chapter number 1 and the name of our chapter is data representation. What is the name?
Data representation.
In data representation, we are going to start a new topic called number system. What is number system?
Okay.
Number system basically is divided into 4 different number systems. The first one is a binary. Binary means
Okay.
base 2. And base 2 means
Yes.
that in binary number system, you have only 2 numbers. Can you tell me what are that 2 numbers?
0 and 1.
Yes. So 0 and 1. Can you tell me 0 and 1 is a language of which thing?
Binary.
Yes.
Sorry.
0 and 1 is a
No.
binary pattern, but it is a language of computer.
Computer.
Or you can say machine. So it is a language
Machine. Okay.
of computer, whatever you can say.
Machine.
Acceptable. Yes, computer.
Okay.
So it means that computer, poor computer, is not able to understand our language. Fine, fine. Now,
Okay.
system is a denary or decimal number system. What's the name of another system?
Yes.
Decimal or?
Denary or decimal?
Yes.
Denary.
In denary, we have base 10. What do you mean by base 10? It means that you have a number starting from 0 till 9. So if you count them
Okay.
with fingers, it will be 10. What do you think? 7.
Okay.
So these are the number pattern 0 till 9 denary. So we humans are going to convert this binary into denary in order to understand the computer
Okay.
language. How? I will teach you.
Okay.
Yes, there is a conversion method. So I will teach you later. But right now, you just need to understand that binary is called base 2, having 2 numbers, 0 and 1. And denary is called base 8,
Okay.
having the number 0 and 9. Okay.
Okay.
Octal is not included in our syllabus, but just for your knowledge, it is called base 8. Base 8 means the numbers
Okay.
till 7.
0 to 7.
Yes. And the most powerful number system is hexadecimal system. Hexadecimal system means base 16.
Okay.
Base 16. It means that we have the numbers from 0 till
15.
so 0 till 9 are the same numbers like denary, but the numbers after 9, like you can say 10, 11, 12, 13, 14, and 15. they are represented by alphabets.
Yes.
So 10 is represented by?
A.
Yes. 11 is represented by?
B.
12 is represented by?
C.
And so on. But
Okay.
the question is, teacher, why did you say that it is a powerful? It is kind of Iron Man? No, it's not Iron Man. It's not Hulk. There's no Avengers. The thing is, hexadecimal systems basically is a language of both. You see, 10 is also represented in a form of A. It means it is going to support humans and computer both.
Yes.
Right? So this type of a language, which is going to use alphabets or the codes, are called, yes, assembly language. Are called assembly language.
Assembly.
So hexadecimal system uses codes and alphabets, which is called assembly language. So this language is understandable, yes, understandable by both, by humans and by
Machines.
computers or machines, yes, by both humans and machines. Is that okay?
Yes.
So what do you have to do? Take out your notebook, write down everything. You have only 5 minutes and send me your written work. I want to see your writing.
Okay.
Go. So we are discussing about the number system, and we are discussing that the computer is only able to understand binary, whereas the humans are able to understand the numbers binary or hexa. So how do we understand the binary language? So we have to do the conversions. So we are going to convert binary to binary. So the first thing for conversion is to understand that the computer stores the data where? In a memory. But that memory where computer is going to store the current data is called registers. So register is a place where computer stores the current data of the CPU. Isn't it?
Okay.
Yes. Register is a kind of a small box. In that box, the computer is going to store the current instructions, just like RAM.
Yes.
Okay, just like a RAM. So
okay.
first you need to understand registers. Basically, we store the data in registers, and the registers are working in a form of a small boxes. In that small boxes are in number 8. So we are going to draw the 8 boxes like that.
Okay.
Why 8? The question arises, sir, why?
Because it's 8 bits.
Excellent. And 8 bits equals to?
1 byte.
Ah, very good knowledge.
Thank you.
Okay, so how do we draw the registers? Like I have drawn the 8 boxes. I need to label it with the help of some numbers. So the first box is called 1. The next box is called 2. The next box is called 4. Then 8.
8.
16.
16.
Then 32.
32.
Then
64.
and then 128.
Yes.
But this is not necessary that in binary we have only 8 bits in question. No, you have a very lengthy questions in binary. So how do we do? So after 128, we are going to double the values. Did you notice something in the number pattern?
It is
Yes.
multiplied into 2.
Exactly. So if you have more bits, what do you have to do?
You just keep multiplying by 2.
Keep multiplying and drawing the more and more boxes. So if you have more numbers, so you're going to take 256 and then 512.
Yes.
Look, I have multiplied it, but right now we don't have this thing. So I'm going to delete it for you. So this is our register, and I have drawn 8 bits. 8 bits equals to 1 byte. 1 byte is the smallest unit we are going to store the data in. So what is the question? Read the question, please.
1 0 1 0 0 1 1 0 infinity.
rate. So I'm going to put these numbers into my registers. So 1, 0, 1, 0, 0, 1, 1, 0. Look, it's easy. After this, we are going to pick only that numbers which are having 1. Like we are going to pick 128. We are not going to pick 64 because it is 0. We are only going to pick 32. Again, no 16, no 8. We are only going to pick 4.
Okay.
2, because they have 1. Acha, haan.
Okay.
Let me tell you a very good thing. In computer, what is the meaning of 1? And what is
Yes.
yes? 1 means on. 1 means yes. And 0 means
Off and no.
yes. It means off. You're going to turn off the thing. So did you see a very interesting thing in your home on the electronic appliances you see? Let me finish it first, then I tell you. Just a second. Yes. Okay. In your home, you see an electronic appliances in your home and you have see this button.
Yes. Yes.
What is the meaning of this button? 1.
Power.
Yes, power. So what is the meaning of power? It means there is a single button. You need to press it for 1. So the television or air condition will be turned on. And if you're going to press the same button, it works for the 0. And the electronic appliance will be off. Is that okay?
Yes.
Yes. So now did you notice why on every electronic thing, you see this type of apple? Basically, this is not apple. This is 1 and 0. Yes.
Okay.
Okay, one more thing. 1 means true. And 0 means?
False.
Yes, very good. False. Okay. So now take the numbers which are having only 1. What are these numbers? Tell me quick.
128.
So I'm going to pick 128. Yes. Okay, then
32.
32, then
4.
Then
Plus.
Okay, what is the answer?
The answer would be
Calculated
okay.
on your fingers.
Yeah. 166.
Yes, that's a great answer. So do you understand how to convert binary to denary? Tell me.
You have to list it down in a register.
Perfect.
And then you have to write down the numbers in the register. And then you have to check which one has 1 and which one has 0. You add up all the digits which has 1.
Very good. So take out your notebook, write down this question, and then I'll tell you the next question. Okay, read the question, please.
0, 11, 00, 111.
Okay, first we have to draw the registers, and then we are going to put the numbers on it, like 1, 2, 4, 8, 16, 32, 64, and 128.
Yes.
This is a number pattern. And then we are going to copy the question like 0, 1, 1, 0, 0, 1, 1, and 1. After this, we're going to just pick the numbers which are having 1, like 64 plus 32 plus 4 plus 2 and plus 1.
Okay.
Tell me the answer, please.
It would be
Your maths is weak, huh?
103.
Yes. This is 103. So this is your question number 2. Now I'm going to give you a question. So you have to do it by your own, okay?
Okay.
That's great. 1, 2, 3. Question number 3 is. Okay, this is your question. So you have to complete question number 2 and question number 3 and let me know. I'm waiting.
Plus 8.
128.
1 plus 8 plus 4 plus 2.
4 plus 2. Yes. So the answer is
2. 398.
398.
Yes.
Okay. So let me calculate first, and then I'll acknowledge you the correct or incorrect.
Okay.
6 plus 128 plus 8 plus 4 plus 2. Yeah, 398. Perfect. So we are going to continue the lesson in the next class. I will share you the schedule of the classes if you're satisfied with my way of teaching. So we will continue chapter number 1, number 6, right?
Okay.
Okay.
Yes.
Here, goodbye.
Thank you.
Thank you.
Bye.
Bye.